Hey everyone, this is Dr. Walker. This is video 38C called Work by Varying Force. In the previous video, we found the work done by a constant force. But here we're going to explore what happens when the force is not constant. In the previous video, we had the definition of work. That work was equal to the dot product of F dot dr. And we said that if we were just in one direction, such as the x direction, then we could say work equals fx dx, delta x. So let's go back to one dimension in the x direction, and let's see what happens when the force is varying. As we can see in this picture here, we have a force fx, but it changes as your object is being moved from an initial position xi to a final position xf. So the way to find the work done by a varying force is to make a whole bunch of little rectangular strips that are very thin and that have a width delta x. If we look at one of these strips and we look at the area of one of these strips, the area is length times width, and the length is our fx, and the width is our delta x. So the area of one of these strips is work. So if we want to find the work done by the force as the object moves from xi to xf, then we want to add up all of these little strips. So the work is going to be approximately equal to the sum from xi to xf of fx delta x. So this means that we are adding up all of these strips. And we can see that if we have an infinite number of strips, so the thickness approaches 0, then when we add up all of these strips, we really are getting the complete area under the curve. So what we're going to do is we're going to take the limits as the width delta x approaches 0 of our summation here of our fx delta x, and that's going to be the integral fx dx from x initial to x final. So to find the work, we just have to take the integral of fx dx. Now, if we want to write a more general definition, in case we are not just in one dimension, then we can say that the work is going to be equal to, we can say the net work, let's say the net work, right, is going to be the sum of all the forces dot the delta r, right? This is if we are in more than one dimension. Now, in general, we are just going to be moving in one direction in this course when we are calculating work. So in general, we will use this definition. We will see it soon once we start talking about springs, because a spring is a force that varies. It does depend on the displacement. So for now, we are just going to practice in the guided example that follows, just finding the area under the curve. And we will come back to using this integral very soon as we start talking about springs.